Good afternoon, everyone. My name is Francis. Today, we shall be looking at some general practical questions covering all areas in chemistry. So sit back, get your writing material, and we shall be right back. All right, let's take the first section. Section A says titration and volumetric analysis. We want to take some questions based on practical chemistry on titration or volumetric analysis. Question 1 says, calculate the molarity of sodium hydroxide solution in 25 cm3 of heat. Neutralize 20 cm3 of 0.1 molar HCl. So from this calculation, we have to start by balancing the equation. We have HCl, which is the acid, reacting with sodium hydroxide, which is the base, to give you a neutralization reaction, which is salt and water, NaCl and water. So balancing the equation, we have ratio acid to base, ratio 1:1. So if you balance the equation, it becomes this way. So from this, we have our molar ratio, which is ratio 1:1. Mole ratio is 1:1. Ca, Va, all over Cb, Vb. That is the concentration of the acid, volume of the acid in cm3, concentration of the base, volume of the base. Here we are asked to calculate what? The molarity of the base, that is Cb. Mind you, molarity is called concentration in mole per dm3. So making Cb the subject of the formula, we have Cb equals Ca Va all over Vb. So given that Ca, which is the molarity of the acid, 0.1, times Va, volume of the acid, which is 20, over volume of the base, which is 25. We have 2 over 25. So 2 over 25 will give us, solving that, we give calculator 2 divided by 25 will give us 0.8, 0.08 mole per dm3. Concentration in mole per dm3, which is otherwise known as molarity, is 0.8 mole per dm3. All right, question 2. Question 2 says, what is the average titer value if 3 concordant readings are 22.50 cm3, 22.60 cm3, and then 22.55 cm3? For you to take the average of this, you look at the difference. It's always plus or minus 0.2. If it is not more than plus or minus 0.2, you are allowed to take. If you look at this, 22.50 and 22.60, the difference is just 0.1. If you look at the difference between this and this, the 0 is just 0.05. 0.05. So you can average of the 3. You take the average of the 3, which is 22, 22.5 plus 22.60 plus 22.55 over 3, 22.55 cm3. Answer. All right, question 3 says, which indicator is suitable for titration between a strong acid and a strong base? When we have a strong acid titrated with a strong base, we can use either methyl orange or phenolphthalein. Any of them can do. So methyl orange indicator or phenolphthalein will do. Question 4. During a titration, why is it important to rinse the burette with the solution it will contain? Yeah, you rinse the burette with the solution of the acid so as to avoid overdilution of the acid in the burette. You have to rinse with the acid to be put in the burette so as to prevent overdilution of the solution. Question 5. Question 3 says, which indicator is suitable for titration between a strong acid and a strong base? When we have a strong acid titrated with a strong base, we either use an indicator called methyl orange indicator, or phenolphthalein indicator. Either of these will do. Question 4. Question 4 says that why is it important to rinse the burette with the solution it will contain? Of course, you know, if we are to put acid in the burette while the base in the pipette, we have to first of all wash or rinse the burette with the acid, because before you use this, you already wash with water. So if you put it directly without rinsing, you are over diluting the acid in the solution. So it is better to rinse this burette with the acid it will contain to avoid over dilution. Question 5 says, if 25 cm cube of 0.1 molar sodium carbonate react completely with HCl, what volume of 0.2 molar HCl is required? In this case, we have to do a balance of equation. We have HCl being titrated with what? Sodium carbonate. So, you know, when the carbonate is involved, we have salts, that is sodium chloride, water, and CO2. Carbon dioxide will be what? Evolved. So balancing the equation is very important. If you balance this equation, since 2 is here, you'd put, 2, then 2. All right. The equation here is balanced. We have ratio 1 of the base to 2 of the acid. So going by this, we have molar volume. We have 2 of the acid reacting with 1 of the base, giving you CaVa, that is concentration of the acid, volume of the acid, all over concentration of the base, Cb, volume of the base. So, and our question is, we are looking for the volume. We said, what volume of the acid? Volume of the acid, which is Va. Va become our subject of the formula, equals 2Cb Vb all over Ca. All right. Making Va, volume of the acid, the subject of the formula. So in this case, we have 2 times concentration of the base, which is 0.1, times volume of the base, which is 25, all over concentration of the acid, which is 0.2. All right. Solving this will give you, multiply this with this give you 5.0 all over 0.2. No. Multiplying this gives you 50 all over 0.2. So 50 multiplied by this will give you 5, yes. 0.0 over 0.2, yes. So solving this further, this will give you what? 25 cm cube. All right, 25 cm3. All right. Question 6 says, explain why a white precipitate is formed when silver nitrate is, yes, continue, is added to a chloride solution. You know, silver nitrate, which is NaAgNO3, with a chloride solution, this is a chloride, will react to give you silver chloride plus the nitrate. So this forms the precipitate, PPT. So when silver nitrate is added to a solar solution, you see a white precipitate because of the formation of silver chloride. Silver fluoride forms the precipitate in that solution. Question 7. What is the purpose of adding a few drops of indicator in a titration? Indicator, as the name implies, is to indicate that equivalent point, or we call it the end point, where acid and base actually neutralize, where certain volume of acid is neutralized by the given volume of base. So that point at which they reach equilibrium is indicated by an indicator with a color change. So that is why indicator is needed in the titration. Question 8. Describe the color change observed when phenolphthalein is used in titration involving a base with an acid. Yeah, when phenolphthalein is used in this case, this is a strong base and a strong acid. The indicator will change from pink to colorless. You know, from pink, when you put the indicator in the base, it shows pink. But by the time you titrate with an acid, at the end point, it will show a colorless. So with phenolphthalein indicator, the color changes from what? Pink to colorless. Question 9. Question 9 said, why should the conical flask be swilled continuously during titration? Yeah, when you are titrating, you hold the conical flask with your left hand and you are titrating with your right hand. You swill. While you are doing that, you are swilling so as to ensure maximum mixture, you know, of the acid and base. You want to ensure proper mixture of the acid and base so as to get that exact point where acid and base actually react together in that titration. Question 9. Question 10. What is the molar concentration of H2SO4 if 25 cm3 of it neutralizes 50 cm3 of 0.1 molar sodium hydroxide? This is an acid-base titration again. We call it neutralization reaction, which involve H2SO4, which is tetraoxosulfate 6 acid, and sodium hydroxide. This is a strong base reacting with a strong acid, which will give us sodium Na2SO4, if you balance the equation, and water. So like we said, it's a neutralization reaction because salt and water is involved. So by the time you balance the equation, it gives you this. So this gives you ratio 1 of the acid to ratio 2 of the base. So in that case, we have ratio 1/2 equals Ca. That's the concentration of the acid, volume of the base, concentration of the base, volume of the base. You know? So our question is, what is the molar concentration of the acid? That is Ca becomes our subject of the formula. Therefore, Ca equals Cb Vb all over 2Va. So in this case, by the time we do substitution, Cb is the volume, is the concentration of the base, which is 0.1 times volume of the base, which is 50, times 2 times volume of the acid, which is volume of the acid is being given. It's concentration of the acid, which is, okay, 25. In this case, we have Multiply this to this, will give you 5/50, which is 0.1 molar, or 0.1 mole per dm cube. Is it that you say 0.1 molar, 0.1 molar, capital M, or 0.1 mole per dm cube? This is concentration in mole per dm cube. Question 11. All right. 11 says that a gas with a pungent smell, and this same gas turn red litmus paper blue. Identify this gas. Yes. The gas that will give us this, that has a pungent smell, and I can always turn a red litmus paper blue, which is called ammonia gas. Ammonia gas, because only ammonia will turn a red litmus paper blue, and then it's pungent. It has these two characteristics, So ammonia gas is the answer. Ammonia is spelled, is written with the formula NH3. NH3. Question 12. What observation is made when dilute HCl is added to a carbonate salt? There's this characteristics of carbonate salt. When you add acid to it, there is an effervescence. You observe an effervescence, meaning you will see a colorless gas will be produced. If you try this colorless gas with lime water, it turns this water make lime water mercury. So the gas produced, which is confirmed by this test, is carbon 4 oxide. So by the time HCl reacts with any carbonate gas, take for instance HCl dilute HCl reacting with sodium carbonate, salt, you have sodium chloride plus water, and then the gas, which is carbon 4 oxide, will give an effervescence. You see, a colorless gas will be evolved. So, which is carbon 4 oxide. Question 13. How can you test for the presence of sulfate ion in a solution? How can we test? Yeah, every salt has got its own characteristic test of identification or confirmatory test in solution. So sulfates can be identified in solution using a reagent called barium chloride. Barium chloride is a reagent used for identifying sulfate. Barium chloride followed by HCl, dilute HCl. So if you have an unknown salt that is suspected to be a sulfate ion, you add some few drops of barium chloride into that solution, followed by dilute solution of HCl in drops and in excess. You discover that by the time you do this, you get a white precipitate, which is insoluble in dilute HCl. That confirms the presence of what? Sulfate. Sulfate 4. This is sulfate 6 ion. So barium chloride is a reagent used for identifying this. You get a white PPT, white precipitate, which is insoluble in dilute HCl. That's a confirmatory test for sulfate. Question 14. Question 14 says, what is the color of the flame? This we say flame test. Flame test is used for identifying cations. Cations are metallic elements in solution. You want to identify the metal in solution. So what is the color of flame when sodium ion are present? How do you identify sodium ion? You identify sodium ion when you put some quantity of the solution in a platinum wire, platinum. You use the platinum over the flame. You discover that the color change will be golden yellow. When you see a golden yellow over the platinum wire, it tells you that the material you're identifying is sodium ion. So only sodium ion will give you a golden yellow flame when tested. with flame. Question 15. Describe a test for chloride ion using silver nitrate. We have said something like this before. Silver nitrate is a reagent used for identifying chloride. So by the time you react the reagent, which is silver nitrate, with a solution of unknown substance containing chloride, if chloride is contained and you add some few drops of silver nitrate, you see a white precipitate. A white precipitate will be given off, which is what? Silver chloride. So this white precipitate is identified to be silver chloride. Question 16. This should be 16. What happens when ion 2, this is ion 2 solution, is added to sodium hydroxide? Ion 2 can be identified using a solution of sodium hydroxide. If you add few drops of sodium hydroxide in ion 2, you get a greenish precipitate will be given, which is insoluble in excess sodium hydroxide. A greenish precipitate will be identified, will be given. That identify ion 2. If you have the other one is another test. If this is ion 3, this one will show a reddish brown. Ion 2 will show reddish brown precipitate, while this one will show greenish precipitate. So that is how to identify ion 2 from ion 3. Question 17 says, what color is the precipitate when lead 2 is added to potassium iodide? Potassium iodide is a reagent for identifying lead in solution. So by the time you react potassium iodide with lead, you will see a yellow precipitate will be given. Yellow precipitate. The solution turns yellow. Yellow precipitate is used to identify lead 2. Question 18. Question 18 says, what is observed when ammonia gas is passed into copper 2 solution? Ammonia gas. When you react ammonia gas in a solution of copper 2, you get a deep blue precipitate. A deep blue, very deep blue will be observed. A deep blue precipitate will be observed, which is soluble, forming a complex ion called copper 2. Copper 2 tetraamine complex ion. Copper 2 tetraamine. So it is given this way. Copper 2 NH4 bracket 2 minus. So the solution will turn deep blue precipitate, which is soluble in excess. By the time you continue to bubble this ion in excess, this gas in excess, the solution will dissolve to form a complex ion called copper 2 tetraamine. Copper 2 tetraamine. So a deep blue precipitate will be formed, which will be soluble in excess of the gas. Question 19. What gas turn lime water milky? The only gas that does that is carbon 4 oxide, which is CO2. Very simple. Question 20. Question 20 says, what is the confirmatory test for nitrate ion? Nitrate ion is written this way with a symbol NO2 minus, NO3 minus, NO3 minus. That's a nitrate ion. The confirmatory test is called Brown ring test. Brown ring test. It is called Brown ring test because by the time you react this thing together, the solution form a kind of ring on the surface of the test tube. You see a kind of ring test, brown in color. So that's why we call it brown ring test. Question 21 says, which gas has a rotten egg smell? The only gas that has a rotten egg that smells like a rotten egg is hydrogen sulfide, H2S, hydrogen sulfide. Question 22. A white precipitate that dissolves in excess sodium hydroxide indicates what ion? A white precipitate that dissolves in excess sodium hydroxide indicates what ion? Indicates zinc. Zinc ion. Zinc ion. Zinc is with this symbol, Zn2+. Yes. Question 23. What happens when sodium hydroxide is added to aluminium ion? Aluminium ion is Al3. Just like zinc, if you add sodium ion to aluminium ion, the solution, it forms a white precipitate which dissolves in excess sodium hydroxide. You see a white precipitate which dissolves in excess sodium ion. Okay, the question says, what test identify ammonium ion? This is ammonium ion. Ammonium ion is NH4+. So the solution we use is dilute HCl. By the time you react dilute HCl with ammonium ion, you see a white film. A gas with a white film will be produced, which is ammonium chloride, forming ammonium chloride salt. So the white film is ammonium chloride. So that is the test. For that, you see a white film produced at the tip of the test tube, which indicates ammonium chloride salt. Question 25. What is the result of heating hydrated copper 2 sulfate? Copper 2 sulfate, when we say hydrated, meaning it contains some water of crystallization. No, copper 2 sulfate, CuSO4.5H2O. So this is hydrated salt. Hydrated salt is usually blue in color because of the water of crystallization. By the time you heat this will give you CuSO4 plus water, 5 molecules of water. This becomes white. So it changes from blue to white. So what you observe by heating copper 2 surface solution is the solution changes from blue color to white color. Question 26. Question 26 says, what confirms the presence of carbon 4 oxide or carbon dioxide in a reaction? We can confirm carbon 4 oxide using a reagent called lime water. Lime water. And lime water has a formula, calcium hydroxide. This is the formula for calcium hydroxide. By the time you bubble lime water into this, it gives you a white lime water. This is lime water reacting with carbon dioxide. This gives you calcium carbonate plus water. You know, this is what will be formed, calcium carbonate. That confirms this. A white precipitate, which is insoluble in excess carbon 4 oxide. 27. 27 says, which cations are metallic ions in solution? Which cation gives a reddish-brown precipitate with sodium hydroxide? The only the cation that does that is ion 3. Ion 3 ion, Fe3+. Question 28 says, how does silver chloride behave in ammonia solution? Silver chloride is a reagent, which reacts with ammonia gas to form a complex soluble mixture called silver ammonium complex, or silver chloride reacting with ammonia will form silver complex mixture, which is soluble in excess ammonia. So question 29, which solution gives blue precipitate with sodium hydroxide? That is, please can we move on? That is insoluble in excess. The only solution that will give a blue precipitate with sodium hydroxide is copper 2 ion, Cu2+. Question 30, which is going to be the last question for today. It says, what color does litmus paper turn in acidic solution? Of course, a blue litmus paper will turn red, indicating that the solution is an acid. So thank you for today's question and answers. I believe you have some. Question 30 says, what color does litmus paper turn in an acidic solution? Of course, litmus paper will indicate whether a solution is an acid or base. And a blue litmus paper will turn red in an acidic solution, which tells you that the solution is acidic. So the color is going to be red in acidic solution, telling you the solution is acidic. So thank you for today's class. I believe you have some questions. Please go down to the comment section and drop your comment. And then don't forget to like, subscribe, and share.